Welcome to week 7, question 2. We're still looking at local extrema, so local maximum and minimum points on a curve or on a function. And the question reads, the male employment population ratio, which is the percent of all men who are employed, can be approximated by the formula shown below, where x equals 4 corresponds to the year 2004. Determine in what years the percent of employed men was at a local maximum or minimum. So let's define what we're looking for. We're looking for the local maximum and minimum, and we know that x equals 4 corresponds to the year 2004, so x equals 0 must be corresponding to the year 2000. Okay, so the first thing we need to do is find the derivative of this function. So let's go ahead and do that. Again, we need to identify the function. We've got 4 terms, 1, 2, 3, and 4. We have 3 powers and 1 constant. Okay, so let's go ahead. P prime at x is going to equal 0.246 x squared minus 4.42x plus 17.4. And remember, the power rule that we were just working with is x to the n. The derivative is nx to the n minus 1. Okay, so now we need to set this function equal to 0. The slope is 0 at the function where you are at a maximum or minimum. Okay, and so we're going to define this as a, this as b, and this as c, so that we can utilize the quadratic formula to solve for x. So we have x equal to negative b plus or minus the square root of b squared minus 4ac, and all of that over 2a. Okay, so we're going to substitute negative b, which in this case will be 4.42, plus or minus the square root of negative 4.42 squared, minus 4 times 0.246 times 17.4, and that's all over 2 times 0.246. And when we solve that, we're going to find that we have x values of 5.84, or x is equal to 12.14. Okay, so we're looking at local max or min values at end of 2005. That's 2000 plus 5.84, and at 2012. So that's 2000 plus 12.14, so the beginning of 2012. So how do we know if they're max or min? Remember, we're going to be looking at the landscape around the extrema, the critical points, to see how the function changes, whether the slope goes from positive to negative through that 0 slope or negative to positive. So I've written the values that we found for x using the quadratic formula. So those are our extrema points. X equals 5.84 and x equals 12.14. And if we look at those values on a number line, let's say we have 0 over here, we have 20 over here, we have 10 in the middle, 5.84 is going to be over here, and 12.14 maybe here. We know here that the slope is 0, and so we really want to just look at the landscape around those 2 points. Is the slope positive before the point and negative after? That would indicate that it's a maximum. Or is it negative before that point and positive after, which would determine it to be a minimum? Okay, so if we look at f prime at 0, so we're looking at the derivative function, substituting 0, we find that that slope is greater than 0, so it's positive. And then if we find f prime at 10, we find that that slope is 0, so it's negative. So you can imagine then that it's positive, coming to that point where it's 0, and becoming negative again. Okay, so we can see then that this point must be a maximum. Okay, so let's look at f prime at 20. That is greater than 0. So we're going from a negative slope at 10 through to the 0 point at 12.14 and positive slope at 20. So you're looking at something like this where you've got a negative slope, 0, and a positive slope. So we know then that 12.14 must be a minimum. Our next step then would be to use those values of 5.84 and 12.14 to determine the percent in those maximum and minimum years of the male employment population ratio. And for that, we're going to go back to the original function, and we're going to substitute 5.84 in for x, and that would find us a value of 71.58%. And we would do the same thing for the other critical point of 12.14, and we would find that that gave us a value of 61.24%. Okay, there you are.